Okay, hi everyone. Today we will learn about data models and transactions. Our plans are divided into by mainly data models, their methodologies, their types, transactions, like the mainly used mostly common types of the ACID and what tasks they perform. When a system is small, every process looks simple. Like some users can create some orders, one app stores one record, just a single resource, single server can handle traffics. But when the system grows, as we discussed on the previous lecture, problems starts appearing with many users write data at the same time. The same data is read many times or write it many times with like these operations, and data becomes huge. They solve real system problems like scale, speed, consistency, reliability, recovery, like as we discussed it before. For that processes, we understand data models, system architecture types, like defines how data is organized and how we interact with it, like the inside the database system. So data models are describes how data is structured and how data is inserted, how data is related to each other, and like the so on. There are three main types of data models, which are conceptual, logical, and physical. As we can see in here, conceptual data model is that describes high-level design of the data. It mainly focuses on the entities and some kind of relations. Like for example, we are built the e-commerce system, and for that conceptual part, we just system like the design about the high-level design. We call it the high-level design. It mainly focuses on the relations and entities, as we say. So like for example, customer part, if you build the e-commerce system. So what else? Product part, order part, payment parts. So one customer places many orders. We can discuss about that in that conceptual model. So one order contains many products. One order has one payment, like this methodologies. So it helps usually understand the system before implementation, like what exists in the business logic, how objects are related to each other. These concepts mainly includes in the conceptual model. So representation or logical data model. It shows how the data is organized in the database system. Like it works with a low level, not high level, just we can divide into by the low, we can deep into the low level model design that includes tables, its attributes, data tables, the database like the data tables and its relations. Like for example, customers has like customer ID, orders has order ID, users have user ID, name, email, and then order price, for example, then another table related to that combined version, like order ID, user ID, payment ID, includes, for example, order item, like this. For example, we can see in here, this is the architecture of some kind of e-commerce platform's logical design, like customer's name, login name, like its password, like this, its address as well, related to the customer, of course. Like in here, we can see these models. All of this includes logical model, like concrete than conceptual model. This is a more intuitive and this is a more logical part of this representation data model. So this is a part of the representation, and like another name is a logical model. The last types of the data model is a physical data model. It shows how data is actually stored on the disk and like the DB system, and like we can see in here like its storage format, like how it will storage in the data with like some kind of JSON format, XML format, and so on. And its indexes, its caches, for example, what kind of memory we can use, like how it will be like the read or write operations, patterns, disk behavior, of course, and plus the programming languages as well, what kind of programming language we can use and which part, for which part. So, and what else? Physical models. Why we need physical models? Because the data is not just stored in the just with the logically or conceptually. It must be able to fast to read, it must be able to fast to write, fast to update, and fast to delete, as we said, like CRUD operations, which are the create, read, and update, delete single operations. And of course, as we talked before, that it must be able to maintainability, scalability, and reliability. So, and after that steps, we can choose the databases like relational, which one is a relational database, which one is documentary, which one is key-valued, and which one is graph-based database logics. We can choose, depends on our projects, depends on our architecture. So this is the main parts of the main concepts of the data models and its types. Of course, the database types also related to our data models and our system architecture, our system design.